man, this is really living.
We're committed to the art and nothing can stop us. Not even a train, plane, tractor, all of us as we feel the rhythm inside the marrow of our bones.
Hey guys, Blue Kool-Aid here. Going to give you a video here. Hey, I'm going to clarify some stuff from yesterday's video just real quick before we go into today's information and stuff that I want to share with you guys today. First off, I got a couple comments, and they're legitimate comments, okay? So I'm not, I'm not upset or anything about any of it. Actually, I like criticism, because it helps me be a better, researcher and helps me focus on what I need to focus on when I'm doing my videos. But I was asked about the computer that, because I know you guys, you see what I'm doing right here. This is, I record on my phone. Okay, and the reason I do that is because my house is so busy that I can't be locked down to one specific spot. I have to move frequently. So if I was to set my laptop up, and I know we can move laptops around, but it's a lot easier just to move a phone. And that's why I do my recording on a phone. But rest assured that I do 99% of my research on that computer. Okay, because it's so much faster. So I just wanted to put that out there because people were asking, because Mike had bought me that computer when I first started my channel. And keep in mind, guys, I didn't ask him to do that. He just did it out of the kindness of his heart. I didn't even expect. I mean, it was so out of the blue that, yeah. And me and Mike have become really good friends since then. I consider him a really good friend. I can call him up. He answers every time. We have multiple conversations, not even just about this, just about life in general. So, it's one of those things. We just developed a really good relationship. So, I wanted to clarify that. Now, the second thing I'm going to clarify is the definitions I was using yesterday. We use these terms elliptical, eccentric, ecliptic, right? So I didn't want to throw a whole bunch of stuff at you all at once. I know when I first got into this that it was kind of hard for me to understand certain things too, although I did know what these words meant, but some people don't. Okay, especially people that are new to this kind of stuff. That's why I keep going back to this, and I keep having, I want to make sure that the newer people can kind of understand, and I try to do it in a way that's fast and efficient, and bring it down to a level that anybody can understand. Okay? And that's not dumbing people down. All that is trying to make sure that everybody understands, because they are smart enough to understand. So, no matter what the powers that be try to tell you. But anyway, we were using these words elliptical, and we're talking about the orbit of, the Planet X object and other, celestial bodies also. We used eccentric, elliptical. Okay, those were the two words I worked on yesterday. Okay, eccentric, like I said, guys, basically means just off-center. Like if you have a bolt that looks like this, that's a regular bolt, right? Yes, I got your guys' jokes in the comment section. You guys have me chuckling. I ain't going to go into those jokes because they, Anyway, we'll move on from that. But that would be a regular, typical bolt looking at it from the side, right? Well, an eccentric bolt would look like this. And I didn't draw this picture yesterday, and I probably should have so people could understand. Okay, see the difference? It's off-center. It's off-center to the right on this specific one. So that's basically what eccentric means. And if you're looking at it from, top down, again, I'm going to use a square. This would be normal. Looking from the, say this is the bolt. You'd be looking from up here, right? That's the view we're looking at. That would be normal. And then an eccentric bolt would be like that. And it can be anywhere. It doesn't have to be off to the right. It can be to the left. It doesn't matter. So basically, if you guys think about this, as it's moving, okay, if you were turning this bolt, say this was a straight shaft, as this bolt is turning, it would do a loping action, okay? In other words, this would be going around that as the center, okay? I know that's kind of hard to understand there, but, and I know it's a really bad drawing, but that is what it is, okay? But the other word was elliptical, and this is where the hang-up came, okay? Now, I use the word slanted just because of how we view it, okay? This is how we look at it in this research that we do here with this object we're talking about. Yesterday I said, and I did say this, okay, and I was, technically I was wrong, okay, but I was trying to bring it down to a level that, we could just use a simple word. But I was, yesterday I told you it meant, we were using it as almost like a slanted word. It would be slanted like this. This would be its orbit, right? Okay, but that's not completely technically correct. So if you look down here, basically, if you look at, this gets used a lot in vocabulary, but we're going to use it here as this definition, the number 2 definition. Basically, you can substitute the word for oval, egg-shaped, and all those right there. Okay? So basically, we're going to use it like egg-shaped. That's a good way to, it really is a good way to explain that. So in other words, I'm not saying that the elliptical orbit has to be slanted like this. Okay? If we're looking at it from the side, it could look just like the way we do orbiting the sun, right? But if it's elliptical, we can't tell the distance. In other words, it could be way over here in its orbit, and then when it comes around to this side of the sun, it could be real close. Okay? So what I'm saying, okay, this, if you're looking from the top down, okay, this would be Earth's orbit. Almost, that's as close to a good circle as I can give you. So basically, as the Earth goes around, it's the same distance pretty much. It does vary some if you want to get technical with it, but for the most part, it's not on an elliptical orbit. Okay, it stays the same distance from the sun no matter where it's at throughout the year. Okay, now this object that we're talking about doesn't do that. Okay, so if you're looking down on the sun, this object, and I'm not going to even draw it slanted. I'm just going to draw it like how I would show it to anybody else. Okay, it's an oval. It's like this. Okay, and what I mean by that is, say today the object is here, and then a month from now it's here. See how it got closer to the sun? Even though it's still in an orbit, it's closer to the sun here. That was my point. Okay, now why did I use the word slanted? Well, because it is in a very steep, that's the word I should have used, steep elliptical orbit. Okay, it's egg-shaped, but it's on its side like this. Okay, that's where I failed yesterday, and I do apologize for that, guys. But that is what it is. So, as you can tell, the distance from the sun to here is a lot smaller than from the sun to here. That's what I meant. That was my whole point, so you guys can understand that word. So, anyway, moving on. We have been having some earthquakes, okay? I started noticing an uptick in this, and most of us here in the community have. It's been going on for years now, actually. A couple years at least, it's ramping up. But I go over here to planetxnews.org, and that's where I go to all my links, and I show you guys this often. You guys should really go read this article. It's a very, very good article. Scott posted this. He does a really good job with this. It's very professional. It's like a news report. He treats it as such, and he does show some of his and Dr. Albert's videos on here too. But go to planetxnews.org, man, and check it out. And then if for nothing else, I mean, heck, look at these. Look at all these links he's got here. Okay? I mean, these are all the tools that I pretty much use. You don't need much more than that. Okay? I know people have their preferences, but they're all there. Okay? So basically what I'm saying is, go here and go to your links, and it's very, very simple to get there. Also, guys, these articles up here, share them, man. I mean, there's good stuff there. Share them with whoever. Show them to your family or whatever. I mean, at least share them to, show them to somebody that you care about, because it's good information. All right. Now, I'm going to go to USGS. And again, this is where I start looking at stuff. Oops. Yeah, this stupid thing is, the filter's set up wrong. I'm going to pause it for a second, guys. Alright, I'm back. This is the ones I wanted to show you, okay? This is over in Japan. Okay, now we actually, Dutch Sense did an awesome video today. You guys need to go check it out. I mean, he was explaining things. Guys, if you guys want to see some good earthquake predictions, go check him out. Please. I mean, the guy has got it under control for sure. And obviously mainstream don't like him because of that, because he doesn't hold to their strict format of the way that they do things. Okay? Matter of fact, he's clashed with them before. But please, go check him out if you guys want good information and good prediction. Go here first. Okay, seriously. Right up off the bat. But anyway, he predicted most of this stuff, guys. He puts out watches and stuff. And again, go to his site and he can explain more. But why do I report on earthquakes? Because space weather affects this. Okay? And I've explained that before. You know, when we get hit with good solar winds and all those kinds of things, that energy, some of that energy does make it through our atmosphere. And it gets to our mantle. Okay? I don't think it can get to the core. It could. It'd have to be really, really strong. If it was strong enough to get to the core, you know, wow. But the mantle absorbs the majority of it. Okay, and once that mantle absorbs that energy, if anybody has, you know, if you guys can remember back to your science classes and things, if it's got energy, it's got to do something with it once it gets too big. Okay, it has to release it somewhere is what I'm saying. Okay, you know, you can hold energy in a specific spot, but only for so long until it builds up and builds up, then it has to release. Okay, so that's basically what happens. Okay, it isn't the only factor in these earthquakes. Okay, I want to make that perfectly clear. But it is a factor. And you'll never see any kind of mainstream organization like USGS here is never going to come out and say straight up that, hey, yeah, we look at the sun right up off the bat. They're not going to say that. Okay, because it's against what they've been teaching people for years. Okay, that's why they don't. That's why they don't say that. But anyway, we started seeing these earthquakes yesterday. I was watching them. You know, they pop off. And you guys, again, go over to Dutch Sense. He runs that live stream all the time. And it's got a globe. And you'll hear a ding, ding. These bells go off, right? So however many times that bell rings, it tells you how big the earthquake was. Okay, then obviously it puts the information off to the left. So go check that out. But anyway, we started seeing fives, you know, pop off that where we've seen these clusters. Okay, down here. Now, like I said, go check out Dutch. I'm not going to go too much into this, but some of that energy has moved up, and he was predicting this, but we ended up with a really sizable earthquake right here. Okay? And it's not the only one. I have to say that. Now, the significance here, guys, is this. That's really, really deep. Okay? It's 375 kilometers deep. Dutch has, and he on his site, he uses it, and most people should, and most organizations do. They have a conversion chart. Okay, what that conversion does is it shows this depth. Okay, and then the deeper it is, the more you have to add to it, to the strength of the quake, the 6.3. So if you go look at their conversion chart, because of the depth of this, you have to add 0.75 to that earthquake number. Okay, and they round up usually when it comes to that kind of a thing. So technically on the surface, according to this, if you go off the 6.3, which was probably downgraded because they usually do that almost every time, and it's really frustrating for all of us, especially people that try to do a report on this. But you add that 7.5 to that, and you get a 7.1. That's what it felt like on the surface. Okay, Dutch was saying that one of these earthquakes here last night, I think, killed like 8 people. And that's why we report on this stuff, guys. This isn't something that we take lightly. Okay, I think this is the one he was talking about. You're down here in the Philippines. And there's clusters of them, man, and they just they're hanging around 4.5, and they're going to 5s, and now then you see this one. So if you add that 7.1, I think the idea behind that is that they're kind of expecting maybe a one about that size somewhere along here after that quake, if it does pop off. I think he said within the next 7 to 10 days, he was saying. Somewhere in this vicinity. And he draws arrows. He explains it way better than I can. But I did want to report on that. Now, if we look at the time of this, Okay, the timing of it was at, let's see here, it says 1831 UTC. Okay, so what time does that mean? Well, that would be 6 hours from midnight. So that's about 6:30 p.m. UTC. Okay, and UTC is Universal Time, so you guys can convert to wherever you're at. I'm on the East Coast of the United States, or Eastern Time, so I have to add, I think, 4 or 5 hours there, or subtract, I should say. So it would be like 2:30 UTC time for myself. Okay, but when we're looking at these tools, most of them use UTC, so you don't usually have to convert them. But if you want to see what time it happened from where you're standing at, you do have to convert. Okay, you can get those conversions. You can go look at time zone charts anywhere on the internet, guys. It's not really that hard to do. Like I said, I think I'm 4 hours from different than the UTC. So if you guys know that if I'm on the East Coast, and you can even subtract from there or add from there and get your own times there. But yeah, so there's a couple things here. Now I'm going to go on off here and show you guys some stuff here. The Magnetopause, guys, is it's starting to go crazy again. Were they predicting this? Well, let's go look. Okay, that's what we're going to do. We're going to go look real quick. Okay, we're going to go to spaceweather.com. It's a NOAA site. Okay, now what's significant about this, guys? There is no storm level. Okay, they're not saying it's a geomagnetic storm, but yet we're seeing these big hits on our magnetopause. Okay, and I'll show you that here in a minute. But if you look down here at the KP, okay, you can, now what I will say, that, it was hanging pretty much at 0 and kind of hanging low, and then it did bump up a little bit here. Okay, but it's not enough to be really that significant. They don't even really say much until it gets into the G1 level here. Okay, now if it gets up into G2, they're definitely saying something. G3s and above, you will definitely know about it. Okay, and they come out and give their storm warnings, space geomagnetic storm warnings, and that's where they get this from. It's like a thunderstorm warning system, but it's for space weather, geomagnetic storms. Okay, typically if we see spikes on the hitting our magnetosphere, this is where we go to look and see if it's an actual storm. This is what's been kind of had us scratching our heads for some time, because we see things happen on our magnetopause, but yet they're not showing up on these tools, these other ones. Okay, so the question comes in, and where did it come from? Okay, the tool's picking it up as if it is solar wind. And it's a lot of the time here as of late, it was not solar wind. It was energy of some other sort that the tool couldn't differentiate. The tool just looks for solar wind. So when it sees a disturbance, it thinks it's solar wind no matter what. So we know that it's electromagnetic fields, magnetic fields from these objects interacting with each other, and it's affecting us here. Okay, so we come here, right? So what were they predicting? Okay, today is the 27th, right? I think it is. Is today 27th? I think so. Okay, yeah, so if you look up here, 27th is here, right? So the conditions at Earth should be right here on the 27th. That's the wind velocity. The density is up here. Okay, so we're predicting the density to be around 2, and the solar wind should have been between, it looks like, 400 and 450, which isn't that high. Okay, that's not, oh my gosh, call 911 type of situation at all. Now this is also a historic chart, so it looks backwards. It can see a couple days behind us. Okay, it shows you what actually happened. And then it tries to predict 5 days out and ahead of us. Okay, so tomorrow on the 28th, they are predicting a small rise in it, but then it's supposed to wall back down. And so what causes them to raise and lower this? Typically, coronal holes. Okay, that will increase our solar wind, and I've explained that before. The sun's atmosphere opens up, to what we call a coronal hole. Okay, and a matter of fact, I think what I'm going to do, yeah, I'm going to just take you guys over here to SDO real quick. Okay, this is the view of the sun from the Earth. Okay, as if we walked outside and looked at it right now from your front porch. Okay, and you can set the time zones here, or time frame that you want to look at. I would suggest everybody go over here to this and check this out themselves and play around with this site and get used to it. Okay, because it's very, very good information. So what we're going to do is I set the times there. You see that? Did I send them both at the same time? I sure did. That was crazy. So the end time should be that day. All right. Now you can set the angstrom of light right here. 171 gold is what it says. If you hit the drop down box, oops. Okay, you can go to all the different angstroms of light. These are just different wavelengths of light. Okay, it looks at it in different wavelengths so it can see better. It sees different things in different wavelengths. Okay, our eyes we only have a very limited amount of the light that's visible to our eyes. So these tools are able to see stuff outside of that, and that's why we look at this. So anyway, what we're going to do, I change it to the bronze one because I do like that one for what I'm getting ready to show you. I'm talking about coronal holes. I think this one's more accurate than the other ones because of its color. If you go look at the purple one on this one, the 211 angstrom, you're going to see what looks to be coronal holes almost all over the face of the sun. And they're not all coronal holes. They may be thinner points in the atmosphere, but they're not all coronal holes. So what we're looking at here, guys, this coronal hole at the north pole of the sun and that one at the south stay there. Okay, those are permanent. They don't go away. They're not Earth facing. Okay, it's called being in the Earth strike zone. Okay, so the Earth strike zone, just so you guys can understand that a little bit better, isn't exactly on the equator of the sun. It's actually just a little bit south. Okay, so with me drawing that picture right there, do you see what's getting ready to happen right here? Okay, this coronal hole, it's pretty sizable. Now, it doesn't mean that it's high in strength. It just shows you the size of the coronal hole itself. So this actually helps me explain also that you see how the atmosphere is split open there? So you can think of this as if there was a bunch of energy and then it's poking through this hole and it gets shot out of the sun. It goes in all directions, but when it becomes Earth facing, that's when we get concerned about it. All right. This will increase our solar winds. The density will most likely probably go up also some. It'll fluctuate here and there. But in the solar wind, guys, very basic term for that is highly charged particles getting ejected from the sun. Okay, that's all that means. That's what a solar wind is. All right, those particles are charged up. They get shot our direction, and this is what we end up with. This is why it's hard for us to understand, because if we see a disruption on the Magnetopause, and I'll show you that here in a second, but before I go there, let me stop right there for a second. I'm just going to go ahead and finish my thought here. But this coronal hole is going to become an Earth facing, okay? It's getting ready to. The Earth strike zone is kind of like right there. So here within the next 12, 18 hours, it's going to come there. Now, does that mean we're going to immediately see an effect on the Earth? No. Okay, now, if we were magnetically connected to this coronal hole, that's how these particles, they travel through those connections a lot of times. So, what I'm saying here is that these things have a speed that they travel. Okay, most of us agree that and I know that some people don't, and that's fine. And honestly, it is. It's fine if you don't believe that the sun's 93 million miles away. That's my opinion. I personally hold that. I do think that the sun is 93 million miles away. That's just my opinion. I can't say for sure. Obviously, I'm not out there with the tape measure, right? But what I'm saying is that, given that 93 million miles marker, If this solar wind that hits us from this coronal hole, say it's moving at 1,000,000 miles an hour, that means it's going to take 93 hours to get here, which is however many days, right? So you're looking usually between 3, 4, sometimes 5 days for some of these solar winds to impact Earth. By the time this coronal hole impact, the effects from this coronal hole impacts Earth, this coronal hole right here will be over here. Okay, now something else we can look at is, you've seen these right here, over here, right? Well, a few days ago, these were over here. So we're probably being affected a little bit by some of these other little small coronal holes. But it's not, and I'll show you here. Matter of fact, I'll just go over there real quick right now. Actually, we'll just look at this one. It gives us a pretty good idea. Okay, now you're seeing right here, I mean, if we look at this one right here, that says 440. That's supposedly the solar wind. It's relative to this model. Okay, you can see this actually looks fairly normal, but what I'm going to show you here in a minute happened a few hours ago is not normal. We got hit with some energy. So, and there's the magnetopause. Okay, that's what we're looking down on top of the Earth right there. Okay, this is the satellite line. Sun's over here, shooting energy this way. So when we see disruptions, guys, that's why we look at the sun. If it's not on the sun or coming from the sun, it has to come from somewhere, guys. Has to. That's when we start talking about the other planet X system that's around in our inner solar system. Okay, it's interacting with the sun and the Earth all at the same time. It's very chaotic. You take two magnets, and I say this almost every video as of late. I know I sound like a broken record, but two magnets next to each other, you can pretty much control. You know, positive to negative, they attract. Negative to negative, they repel. Positive to positive, they repel, right? Pretty straightforward when you're talking about two magnets. You throw a third magnet in there, and it gets really chaotic really fast. Okay? They start interacting, all three of them together, and it does way different things than what you think it would. Then you add a fourth and a fifth. I mean, then we're talking some stuff that it'd be almost impossible to predict what stuff was going to do. And also, when stuff is traveling magnetically, it's almost moving at the speed of light. These electrons are moving at the speed of electricity, those kinds of things. So the energy actually travels very, very fast. It's faster than a solar wind. Okay? So it can. That's you know, it can do that. It doesn't necessarily have to, the energy doesn't have to travel that way. But what I'm saying is that when we look at these models, you know, that's why we look outside of the sun when we don't see these coronal holes. When we see the uptick in the magnetopause models, right? So, what we will do, I'm going to go ahead and go on over here to ISWA. I'm actually going to pause it while I load this up, guys, to save you guys some time. Alright, guys, I'm back. Just want to load those up for you so you guys can check them out. Okay, so what we're looking at, guys, is magnetopause. If you look at the timestamp down there at the bottom left, it says 27. The date's the 27th at 5:40 UTC. Okay, that's how far back I've got this going. We could go back further. I've seen some disruptions even before that. But we're going to check this out from this timestamp forward, okay? You're going to see some pretty good stuff here. What you're seeing, guys, you watch out in the front. You see the energy starting to build. Now, what I've found here as of late, it's almost as if the front side and the back side, the whole thing. See how we were talking about egg-shaped earlier? This whole thing looks very, very egg-shaped. Okay? Does that mean anything? Well, it kind of means that we're getting pushed on from both sides. Okay? Keep in mind, sun's over here, and we're looking from the top down. Okay? We're looking on top of the Earth there. This, again, is the satellite line. The dotted line is the satellite line. So the majority of the energy that we get should be coming from the sun. But when we don't see those coronal holes, because that's what we've been talking about, it didn't come from the sun. We didn't see any CMEs, no solar flares, nothing like that. So it's got to be coming from somewhere. It could be cosmic rays, which is a good possibility. Some of it is. the electromagnetic disturbances we were just talking about with the magnets and all the Planet X object really affecting, and it probably has a pretty decent strength, very strong magnetic field, so that's why it's able to disrupt it enough to really affect and see these kinds of disruptions. So anyway, we'll toggle through here real quick. Now I'm going to go through this kind of fast because I show this a lot, but we're seeing, and when I see something that I don't typically see, I'll stop. But that is something I don't typically see. Okay, if you guys have watched my channel very long, you'll know what I'm talking about. You see how we got pressure building up here in the front, right? That's basically, we can think of this as heat, where we see the red. Obviously the key is down here, so the blue's colder, okay? I'm sure technically it's a little bit different than just saying it's heat, but we'll just use that term for here. But do you see how it's building evenly back here? Okay, now if you guys look at the front and compare it to the back, what's the difference? There's not much difference there, is there? Okay, this is my my thought, I guess you could call it. I don't know what's causing this even amount of large pressure coming from the backside. Okay, because typically, and I'm just going to say this, usually when we see this pressure build up, we do not see it when it comes around the backside here. We don't see it bend like this around the planet. We do sometimes, but not like this. This is almost, it's really, really strange. It's a strange signature that I've not really had too much, too much thought on this, because if you look at this, what we typically see is you'll see energy build up kind of like in a line, like this, and I'll show you some of those here in a minute. And then it'll be just kind of concentrated right here, and sometimes this right here doesn't even get too much. You'll see it build up here on the sides, go to those red colors. But this isn't what we're seeing here. Okay, what are we seeing here? That's my question. We're seeing that this is definitely building very, very evenly in the back. And like I said, do I think there's something behind us causing this? I don't know. I don't think anything is like extremely close causing this, but I can see cosmic rays coming from the backside there a little bit. And this is going to lead me into a discussion here in a minute, guys, that I think you guys want to hear. It's stuff that we need to see and talk about. So you're seeing those waves out in the front, right? Okay, we're getting hit, right? Boom, we're seeing this bouncing, and I've talked about this before too. We're probably going to get a compression here in just a second. I can kind of see it coming. Now something else. Watch this, guys. Now do you see, if you guys can see the blue, right? You see the difference in the color of the blue? Like this number? You guys are going to see all those tilt the same time, same direction this way. Okay, basically instead of looking like that, it's going to rotate. What it looks to rotate, the front side is going to go that way and the back side is going to go that way. Now watch. I haven't looked at this yet, so I guess I could be wrong. But I think that's what's going on here. Okay. As we go forward there. Yeah, see it moving down? Okay, I know it's kind of hard to see, but if I do it faster, you'll see it. See how it's kind of almost directly on us? Like, just horizontal? Now you're going to see it kind of tilt to the bottom a little bit. And again, I know it's kind of hard to see, but anyway. See, that's a good way, because it's tilted there. See it? So the energy really is coming from out here, all right? At least according to this. Now it does show that right here the red is, so we could be getting hit there. I don't know why we tilted down like that, but I do see that a lot. Now, when I say we, I don't mean the Earth is tilted. Okay, I got to make that clear too. Just the magnetics as tilted that way. Okay. So we'll keep going forward here. You seen that bouncing? And then boom. Okay. Look at this. Watch this. Oh man. Look at that, guys. Okay, this is what puzzles me. This is when I start questioning stuff. So what am I talking about? Right? Look at this. right here. This is our shield. See this line right here? That's technically our shield. Okay, basic position of it. So why is it staying out here, but yet compressing on the sides towards the Earth? Plus, that's part of that line too, so it would look like that. I mean, and all this stuff going on here in the back is not normal. That's not a normal condition signature there. Okay, and this is just happening like right now, just so you guys know. And as I go through this, okay, now you see now it's pushing, the Earth's pushing back out, and it comes to be almost a normal one again. And did you see that right there? Okay, what I'm talking about, I want you guys to watch right here. As I move forward, you're going to see nothing happen out here, but we're going to discharge something this off of the Earth this way. See that? See how it got different color there? And more bright there? And it's going on out. You see that? How it kind of flipped? Like kind of flung? Like flicked your finger? See that? That means that energy went that way. Okay, that's what that means. And it looks as if we're starting to have another reaction. Yeah, we are. I can tell you that right now. We're getting hit again. Right as we're talking. So, but I won't go into that part of it. But I'll show you these other models real quick, and you're going to see basically the same types of disruption, just in a different way. This is the solar wind model right here. Okay, so that's the actual wind speed. At least that's what this model's trying to tell you the wind speed is. Okay, and again, I have to keep saying this. It may not be winds. It could be energy being caused by all these other sources. Okay. And what I find odd right now is we're getting these disruptions, but this wind speed is actually lower than normal. Okay? If it gets below 300, between 300 and 250, that's really the low end of normal. Okay? So if it gets up above, we really don't even start looking at geomagnetic stuff till it gets to like 500. So, okay, now you've see how the wave came from the front there, watch, see it? Okay, and then the wind did go up just a little bit. Not huge, didn't even get to 400. Then another one right behind it. You see that second wave come in? Okay, that's when it gets a little bit choppy, because when we get hit with energy, and then we get hit right behind it, our shields don't have enough time to react. Okay, so when we get stuff really close together, that second wave that hits us is probably going to affect us more, because we don't recover as fast. We don't bounce back as quick. Okay, I've yet to see that solar wind get to 400. I mean, that's just odd. Now there it goes. Okay, so we're getting some 400s there, but it's still not that high. That's pretty much a normal. And something else I've noticed, as I toggle through there, it's like the energy is sitting here just spiraling. Okay, watch the directions of the arrows. See how they're not changing much? That means that they're moving in the same direction for that duration of time. We don't typically see that. Okay, this is something else that like I said, we're seeing some strange stuff here. So, okay, that's a decent sized hit right there. You see how our bow shock out in the front, the big thick red line? See how it got real thick and started to expand it out? That means it's trying to fend off stuff, guys. It's getting hit with energy. Okay. Now again. Okay. Ooh, look at that. Wow. Okay. Yeah, now we got something to talk about. Woo-wee. Look at that. 1241. We'll go convert that here in a minute. Wow. How do you go from, that's like a 1,000 increase. Kilometers per second. Oh, wow. 1474. What the? Whoa. That is fast, guys. I'll show you what I'm talking about here in a second. Holy smokes, Batman. 1474. Wow. Okay, but what I want you guys to notice, okay, we didn't see any red here. Okay, the intensity of that wind. But yet we've seen a big disruption come like right here, like a ball of it. So where'd that come from? Okay, as that, watch. See, we're getting hit on the front. Now, we are getting hit. You see our bow shock moving? Okay. Now, that's, yeah, we are. We're getting hit. But is it hard enough to cause that? Evidently, it is. Okay, see how that just exploded out and all that hit happened? All right, now look at that. Look at the thickness of our bow shock. Okay, then we start calming down. And look at that. Went right back up. We got hit again. Okay, now look. Now guys, as I'm making this video, that is real time for me right now, okay? That's the last capture we get to see while I'm making this video. I can tell you right now we're getting hit again. At least something's happening right now. Because if you look, watch the wind speed. Okay, you're going to see it climb. It's going to start climbing. It's going to get to about 600, I think, is what it showed. And you're going to see like a little ball outside the back of the earth start happening. See that? Now, when I get done with this video, I'll go back and check it real quick before I let you guys go. But you see that? Something else is happening right there. But this right here, right about, see how wave, boom, we're shaking, and then bam. Look at that. That got, I mean, that's a hit. When you're talking 1,474 kilometers per second, I'll show you guys here in a few minutes what that computes to. But as we go on through, like I said, okay, and we seen that. That's when that thing started acting up. So, this is the other model. This shows you the blue lines here, guys, are our connection to the sun and other celestial objects. The black lines are our pole lines, north and south pole lines that come off the earth. And then the red ones are just closed circuit lines, okay? Now, like I said, the most important one's probably the blue ones, the IMF, intermagnetic field lines, interplanetary magnetic field lines, I'm sorry. It's basically the sun's it's basically the sun's magnetic shield for the whole solar system, okay? And we're connected to it. So, obviously you're seeing some disruptions. Yeah, you're seeing the red. Okay, I'm anticipating something huge hitting right here. Just judging off that other model. Now you're seeing all those blue lines get broke, right? That means the connection to the sun's being broken right there. And other objects. Doesn't mean our connection is completely gone. It just means that one particular connection isn't there. Okay, it's been broken, disrupted. Okie dokie, here we go. I can tell you, okay, whenever you see that signature, see how straight line that is? I've seen these models enough to know that majority of the time when we see that, you'll see a big boom, just like that. Okay, now is this solar wind? I ain't saying it's not. Well, look at that. See, we got a second one coming, just like I showed you a minute ago. I don't think it's all solar wind, though, okay? That's my opinion. Just judging by the predictive models I showed you earlier, they weren't predicting anything like this. Nowhere did they tell me that there was going to be a 14-something, wind speed. Okay? Not even close. Now, that was just temporary. I think they take like averages, and that's how they do their models and stuff. But what I'm going to show you here, guys, this is basically our Van Allen belts. It's our radiation belts, okay? And these are basically based off the same kind of models, all right? Same data. But it shows us radiation at different levels. The typical one that I like to show is the 50 Kelvin. The Kelvin's just a measurement of energy there that they use for this, okay? Radiation. So, what we're looking at basically is one of our, or part of our Van Allen belts. The ones the astronauts have to go through to go get out into space, like to the moon and stuff. And I know there's a whole big controversy over that. I'm not even going to get into that. But what I'm trying to say is that this right here is something that they had to deal with at the space agencies to get through this. Okay? There's like I said, there's a big controversy over any of that stuff. So, as you can see, we're getting hit. Okay, now that when you see that pink pop in there, that's very intense. Okay, now, this right here is when the magnetopause started to jack up. Now you see that? Wow, guys, holy cow, look at that. That's massive. That's, yeah. So why am I showing you this one right now? Well, I'm going to back out of this ISWA. I'm going to try to end this video here in a second because I don't want you guys to have to stick around too much longer here. But I come across something on the 24th of July that nobody's really talked about yet. And I'm not sure if anybody really paid much attention to it. Okay, because it was just very, very short event. Okay, let me back out of that. Go to that one. Yep, okay, that's better. That's the same model I just showed you guys, the radiation belts. What's different about this one, guys? Can you guys tell? Well, if you're looking at this model here, the sun's over here. So why is the energy coming from this direction? Why are we don't have any... See this black line? That's basically our shield. We don't have a black line out in front. So anything coming from the sun at that particular time is getting straight through. Okay? Now this only lasted for like a half hour. Okay? We've seen some magnetopause reversals back in 2012 and subsequent years since then. I did videos. Multiple people have done videos on it. There's some stuff where they actually scrub some of the data from the net. And you can't even find it anymore. But there were people that were able to record it. And they've got it themselves. So we know that it actually happened. And it was like a day-long event. This here was just very, very short-lived. Okay? So you guys can see that it looks as if the sun's over here. Is what I'm trying to tell you. So it reversed there. Or I don't want to call it reversal. We were protecting ourselves. We formed some sort of a barrier back here. And we became open in the front. Now, was that a complete magnetopause reversal? I don't know. Okay? All I can tell you right here is that this is not normal signature. I can tell you that straight up. Okay, and I did it in all different Kelvin levels here because you can see these are all different. This one is, let's see here. This one's 50. That one might even be 10. I don't even... That's really not that important for what I'm trying to tell you right here. But they incrementally go up. Okay? That's why I made this little sheet here. Okay? So I wanted to show you guys that because that is definitely not normal. Okay? So what we're going to do here real quick before I get you guys off of here. We'll go back over to ISWA for a second. I'm going to pause it. Alright guys, I got you back. I got these loaded up for you. I'm going to show you the first one there that I showed you guys a minute ago. The first ball of energy here. It comes off the back. Okay. That was caused from the front. It came from that direction. It doesn't mean it came from the sun though. Okay. I have to point that out. Now, don't get me wrong. I really truly think that some of it is coming from solar wind. But all of it is not. Okay. Some of these disruptions we're seeing cannot be related back to the sun. So we have to look other sources. The Planet X object gets close enough to the sun and to us, and it affects us electromagnetically, and that's why these things happen. At least in my opinion, okay? It is my opinion. It's just what it is. It's not, anything more than that. But we're building more and more evidence here, guys, of, our 28-day theory that Scott's come up with. All that stuff is, when we're able to predict where the thing's going to be, that's pretty good evidence in my opinion. So, but anyway, there's that first one, right guys? And you can see what happens when we get hit real hard. And I'll explain real quick on that end of it. You see all those blue lines? Remember I said the blue lines is our connection to the sun? Obviously that connection is getting all jacked up. You can kind of think of it, and this isn't really technically accurate, but like a short circuit. That's kind of what happens when these disruptions hit us. Okay? So keep that in mind. And also, like I said about the earthquakes, guys, whenever we get with these big energy, this energy stuff that happens out here, okay? Remember I said some of this stuff is making it through our shields? Well, where does it go? It absorbs into our mantle. All right, and then, you know, the Earth kind of absorbs some of it. Well, it's got to let it go somewhere, somehow. And a lot of times it's through these earthquakes. That's why the intensity is ramping up. That's why the frequencies have been ramping up. Guys, I mean, we really got to pay attention to that. That's going to be big. It really is. But here you go. Okay, that's that first one. And then this one here is the one I was just showing you live. You see that? Okay, that one there didn't turn out to be as big. Okay, but it was something. Okay, that wasn't such a big hit. Now, the last thing I'm going to do here, guys, is show you we're going to convert that supposed solar wind speed. Okay, you know, can I say 100% for certain that was not solar wind? I can't say that. Something hit us that fast. Okay, it was moving that fast. That's what the detector picked up, right? So we had it was we're just going to call it 1470. That's kilometers per second. Guys, you guys can go and get these converters anywhere on the internet. They're free. You can change what you're trying to convert to. They're very simple to use. Anybody that's trying to look at these tools, please go get one of these and you're just download one, have an app or whatever on your desktop or have it on your phone. But you can do it really quick here, okay? But anyway, you guys are going to be very, very surprised on how fast this actually is. Okay, this is kilometers per second, 1470. Okay, according to that model, that's what it said. Okay, we are going to convert that to miles per hour. We're looking at 3,288,000 miles per hour. Okay, so something's moving at, we'll just call it 3 million miles an hour. All right, in a 24-hour period, let's see here. Yeah, does it take it 24 hours? Let's see here. Let's go 3 million. Actually, you know what? We'll just do this. Let's see if I can't get to my... Have a calculator right there somewhere? I think I do. Yep. 93 million miles. Okay, we'll just go 93. Let's simplify that. 93 divided by 3 million, right? 93 million divided by 3 million equals 31 hours. Just a little over a day. So if that wind speed was actually that fast, so if we go back and look at the sun on that day, which had just been yesterday, okay, or the night before, you know, so you guys take that for what it's worth. You know, and we've been looking at SDO and stuff too. I mean, the seed site. I'm not going to go into that in this video because it's already way too long anyway. I know I got you guys here for a while. But yeah, I just want to clarify some stuff there, and I did want to show you guys, you know, when we start seeing this stuff happening more and more, basically it switched to the other side. And then, like I said, this was a very short-lived, but when we see these kinds of anomalies, we've got to pay attention. And then when we don't, and then when we see this, okay, that's not normal. Okay, it's not a normal signature. We have to keep that in mind. All right, and again, I'm going to show you this too. Remember I showed you guys this yesterday? Those two stars orbiting each other, doing a dance, binary system, moving at, they were rotating around each other. It only took them 7 minutes to do so. 6.91 minutes. You guys know how fast that is? I mean, it's extremely fast. So for somebody to, you know, it's just more proof that we do have these objects in, you know, because if these objects are close to the sun, they're moving as fast as what we've shown, it's not, you know, out of bounds to think that, you know, it just gives more proof to this object. It can be that close to the sun. and move in a 28-day orbit. Just saying. Okay. So anyway, you know, and this here too, this is a flux model. We start seeing these spikes, okay, and we're not seeing any increase in the solar wind. So that's where some of this disturbance is coming from. Okay, this picking up on some of these disturbances. Scott sent me that one. That's a very good model to look at, by the way. All right, so, you know, always in with that, right? No fear, no dogma, no worries, no drama. Let's keep it that way. Stay strong. And yeah, okay. So, God bless. Yeshua saves, and you can drink this Kool-Aid.